Hey there, ladies and gentlemen, boys and girls. Today I'm here to show you guys a new update to our periodic table based on what we've been talking about with ions. All right, so I'm going to kind of run through this kind of quickly here, and then we can update our periodic table with a new trend that we have on our that we have here based on their ionic charge. All right, so what I have over here is I have all the elements in period 3 going from left to right. All right, going from group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, all in period 3. All right, and we already know that there's a trend across from left to right on the periodic table based on valence electrons. Right, 1A has 1 valence electron, 2A is 2, 3A 3, so on and so forth until 8A where we have a full outer energy level. All right, well that's going to relate to how we do with our octet rule and our full charges when we get there. So just kind of going through this relatively quickly here. All right, sodium has 1 valence electron, which means it's either going to try and gain 7 more or lose 1. It's going to lose 1 electron, becoming an ion of a +1 charge. All right. Magnesium has 2 electrons. It is going to lose those 2 electrons and form a +2 charge. Aluminum has 3. It's either going to gain 5 or lose 3. It's going to lose 3 electrons, becoming more positive, and be a +3. All right. Now this one is tricky here. This one's tricky, all right, because we have 4 valence electrons. It can either gain or lose 4, or either gain 4 or lose 4 electrons. Which one's easier? Well, it's actually one of the defining factors of what makes a metal versus a non-metal. All right, metals form cations. Non-metals form anions. I'll say that again. Metals form cations, positive ions. Non-metals form anions and are more negative, or negative ions. All right. So it could be +4 if it's a metal. That's a capital M. All right, and it would be -4 if it's a non-metal. All right, in this case here, actually silicon acts like a metal, in this case it forms a cation, but it can be either or. So we have +1, +2, or +3, +4, or we could be -4. That's 5 valence electrons. 5 valence electrons, it's either to gain 3 and become more negative. So then we're to -3 anion. We're going to gain a 6 valence. We're going to gain 2 more, become a -2 ion. And we're going to gain 1 and become a -1 ion. All right. And then argon, right, has a full outer energy level. Right? So it's not going to gain or lose any electrons because it is already happy. All right? It's not going to gain or lose any electrons, and so it doesn't form an ion. All right? With 0, none, however you want to do it. So we see a pattern from left to right. We go +1, +2, +3, +4, or -4. -3, -2, -1, back to 0. So on your guys' periodic table, get those out because now we're updating them. All right. We know that we have our group A elements, our groups. All right. We know that they go up and down. We've added valence electrons to these. It's getting kind of tall, the stacks here. All right. What we are also going to add to them is their ion charge. Those elements in the same groups have a lot of things in common. All right. So group 1A, all the elements here have 1 valence electron. which means they're all going to lose that 1. Become +1, except one of them. All right? Hydrogen is the only exception. Because it only has 1 electron, it's not going to try and lose that 1. It is going to try and gain an electron and forms actually a -1 because it is a non-metal. Non-metals form anions, right? So except for that hydrogen there, right, hydrogen is going to be a -1. The rest of them are a +1, +2, +3. All right, I'm going to write for this one +4, parentheses M for metal, -4, parentheses NM for non-metal. All right, so you have to determine if is it a metal or non-metal. If it's a metal, it forms cations, that +4. If it's a non-metal, it forms anions. And then we go to -3, -2, -1, and then no ion. All right, because those noble gases already have a full outer energy level, they don't want to gain it. All right, so it's a pretty straightforward pattern. There's only 2 really things that we have to really pay attention to. 3 things. Number 1, the group 4A, if it's a metal, it's a cation. If it's a non-metal, it's an anion, which means a positive ion versus a negative ion. Just have to pay attention to that. Group number 2, group 8A already has a full outer energy level, so it does not form an ion. Ion's an atom that gains or loses electrons. It does not need to, so it does not form an ion. And then, of course, hydrogen is a unique one here. It is in that group 1A because it has 1 valence electron, right? But because it is in that first energy level, right, it only has 1 electron. And so it actually wants to gain another 1. And we already know that even though hydrogen's already over here, it is a non-metal. And I just said, non-metals like to form anions. All right, so there's our newest update there. You should have that update on your, this part right here, sorry. This part over here should be updated on your periodic table. We added the ion charges to them, including the specifics about hydrogen. Otherwise, if you were missing some of the explanations on some of the more special cases, go back and listen to those ones again so you understand why those are the way they are. Otherwise, thank you very much. Good luck, and may the science be with you. Bye.